My name is Patrick Robb. I'm coming from the University of New Hampshire InterOperability Lab. And I'm here to give a talk about the DPDK test suite, or DTS. We just had a wonderful conversation between a bunch of interested folks about it. And sort of based on that conversation, I'll note at the start that DTS is a end-to-end testing framework for DPDK, where basically it sets up multiple nodes, and one node will send traffic, the other node will run some DPDK application. TestPMD would be some example. Then we write some test suites that will set up TestPMD, set up the TG, run some workload, do an assertion, and the test will pass or fail. And I'll note that we're running this in a CI lab, but it is not intended to be used exclusively by CI labs. It can be used by individual developers as well. There was a talk at DPDK Montreal last year about how to write test suites and how to run DTS. So I'm sort of building off of that by providing a practical example. And the practical example here is I'm sort of outlining how we set up the framework in our lab automation and sort of what the experience was like for us deploying DTS in basically our automation framework that backs the DPDK community lab. Anyhow, I'll get right into it. So some background information about the InterOperability Lab and about its relationship with the DPDK project. So the Interop Lab has been hosting a community lab for the DPDK project for some years now. And what we're doing is we basically have some bare metal resources, and we also maintain like a cluster that that basically backs some virtual machines. And we'll run some testing on that. Basically, we run some software testing on the virtual machines, which is like build and unit tests. And the unit tests are being driven by the DPDK Meson test framework. And then on the bare metal side, we'll run some of those end-to-end tests that, again, are sending packets from one node, receiving them and processing them with a DPDK application on the other node, and validating that the behavior is correct. And that's the DTS side. That's the thing that's testing the bare metal functions. Or the end-to-end testing of a DPDK application. Okay, a couple of other things to note about the community lab is that it's a CI testing lab, so we're doing testing on a per patch basis. So what we do is we monitor the DPDK mailing list for new patches that are coming in from developers. When one arrives, we grab it, we apply it to a particular DPDK tree, and then we run, again, those build tests, those unit tests, and those DTS tests on our hardware. We also will do basically a nightly periodic test on basically all of the relevant DPDK branches. So that's like mainline, the next branches, and then also the LTS branches, so 2211, 2311, 2411. And the final point is that I'll just note that the community lab exists because it is funded by the DPDK project, and that's coming through the gold members. So one of the benefits of being a gold member is that they're able to send their hardware to the community lab or request that particular hardware be brought into the community lab, and then we do so. We integrate that into one of our test beds. And again, then we'll start running the testing over that hardware. So proceeding on here, I also want to call out a few repos, which I might mention during this talk, just so that there's no confusion. So the first is the DPDK repo. I'm sure we all know that one. But the important thing to note there is that the DTS framework that I'm talking about is the one that is a subdirectory at the top level of the DPDK repo. There's also a DTS repo which is existing on dpdk.org, and that's the legacy DTS repo. So if this talk inspires you and you want to try and deploy this application and make use of it, just make sure that you're cloning DPDK and you're setting up the application, which is in the DTS subdirectory under DPDK. The other repo that will be involved with this talk is the DPDK CI repo, and that's basically a set of scripts which combine to form a CI reference lab. So those are some scripts that can be used for doing all of those tasks that are required to set up a CI lab, like polling patchwork, polling and then pulling the patches, applying those patches to a particular tree, running some of the testing, sending the reports to the test report mailing list. Okay, moving on. I also wanted to just provide a few pictures of the bare metal resources that are at the lab. So we've basically got 2 racks, and the one which is on the left here is the first one we had set up. So that's got some eclectic mix of Intel, AMD, and ARM-based systems that have come in over the years. Some of them are quite old now, and some of them are brand new. So for instance, at the bottom there, we've got like an ARM-based server that we actually got in only a couple months ago. And then on the right side, that's the second rack that we've also been setting up recently, which is all pretty much quite new hardware that came in last year. So again, DTS will get run across these systems, and these systems basically will be paired up against one another. One will be acting as a traffic generator, and one will be acting as a DUT. A DUT or a SUT. Device under test, system under test, same thing. So I'll just overview the topology as it is being set up in the community lab right now. And then at the end, I'm also going to talk about what are the other things, the other ways that you could set up your topology. So basically, you've got 3 entities that we care about. One entity is the traffic generator node. That's what's going to be sending the packets and sniffing them at the end. One entity is going to be the SUT node. That's going to be running some DPDK application. Test PMD is what we're doing in most test cases. And then you've also got the execution host. So that's what's actually running the DTS Python application. And that application or that entity is responsible for controlling the TG node and controlling the SUT node. I'll also point out that you can see there's 2 links that we have here in between the traffic generator and the SUT. That's sort of the standard topology that we're deploying at the lab. Different test suites will have sort of different physical requirements written into them as Python decorators. There are some that do not require 2 links, but rather require 1 link or none. So if you're only able to set up, sort of a smaller topology, you can run a subset of the test suites that exist within DTS, but that's just the one caveat there. And final thing to clarify is that the TG node and the SUT node, we're setting them up as 2 servers connected back to back, but that's not actually required. If you'd like, you can just have 2 NICs, which are both hosted on the same server, connected back to back. So it is flexible. All right. So we've got the servers, we've got the NICs, and the desire to test DPDK. Before I talk about how we sort of set up the automation for running DTS in our CI lab, let's just do a quick review on how we go from 0 to running DTS. And it's not a very difficult process, I promise. So to start, you just clone the DPDK repo, or otherwise go to your DPDK source where you've not configured DTS already. You need to set up your SSH user and give that user passwordless sudo on the node or nodes that are making up your testbed. Then you need to fill out the configuration files, which you can find under, again, DPDK/DTS. It's not too onerous. You basically have to set up a nodes YAML configuration file. That's where you provide the server info, the NIC info, huge pages, configuration, etc. And similarly, you need to provide a testrun YAML config file. And that's going to point out, which node is the traffic generator, which node is the site. Do you want to use any VDEVs? What are the build options which you'd like to employ? Which test suites to run? Stuff like that. Then the next step is that on the DTS execution host, you need to meet the Python dependencies in order to run the application. This is also not very difficult. Basically, we've integrated Poetry with the framework, so you can just use Poetry to install the Python dependencies. For those of you that aren't familiar with Poetry, it's just like a fancy requirements.txt, but just with a few more free features. But that's pretty much a simple process. So that's something that you can probably do in a matter of 10 or 15 minutes, most likely, or less. And from there, you just run Poetry run Python main.py, sit back and wait a few minutes or 10 minutes, however long it takes for the tests to execute. And then when they're finished, DTS will produce on the execution host, it will produce an output directory. And within there, you'll find a human-readable summary text file, a sort of machine parsable results JSON file, which is more helpful if you're using the application in like an automation context. And then also it will provide some test suite specific log files. So if you're looking for why a particular test suite is failing, then you'd want to look at that particular file. So it's really not super difficult, and in fact, we found when we deployed the application into our CI lab, we were able to do so pretty expeditiously. I'm just providing an example config that we're using on one of the systems. Again, it's not too crazy, so you're going to want to provide some arbitrary name for the node. You're going to want to provide the host name of the system, what the user is that has the passwordless sudo permissions, what's the operating system, what are the ports that are making up that topology, and within there you just provide some basic info. What's the bus address, what's the kernel driver, what's the DPDK driver, and the framework will use that to obviously bind to, say, VF5 PCI before we start test BMD, or bind back to the kernel driver at the end. You can set your huge pages configuration, etc. I've kind of cut it off at the end here, but similarly, you'd provide some basic information about your traffic generator. So, what we did is we set up this config on one of our test systems. It was pretty easy. Here's the other config file I talked about, the testrun YAML. Again, basic info that's important for DPDK applications. What are the L cores to use? How many memory channels do you want to employ? We have some configuration for the DPDK source and build options. So do you want to provide a DPDK tarball, or do you just want to provide an uncompressed normal DPDK directory? What are the build options? Actually, I'll call out that Wathsala's talk from earlier made me realize that we really should have like a Mason options or a Mason flags key value here. So I made a ticket for that, and we can add that. And then again, some basic information. What is the SCAP? What is the traffic generator that you want to use? What are the test suites that you want to run? You can either provide a subset or just leave it blank, and it will run the whole set of tests. And again, which system is the traffic generator and which is the site. So it's not a big lift to configure, I promise. This one is going to be less relevant for individual developers that want to run DTS, because they do not need to use Docker or containers in order to do so. But for the CI labs, we are providing a Docker file. And the reason is because we don't want to have this problem that containers solve of, it works on my system, why doesn't it work on your system? So we did just write a simple Docker file that will meet all of the dependencies between the sort of Ubuntu. Well, you don't have to be using Ubuntu, don't worry, to run DTS, but meet all of the basic dependencies, meet the Python dependencies, and then start the framework. So basically what happens here is that it meets the dependencies, and then we define an entry point. That just means that when the container gets starts, it runs poetry run Python main.py. The framework will execute for a few minutes, and then once the main.py script exits, then the container will exit, and our automation proceeds. So this has sort of made our life easy. And that you can just find that Docker file in the DTS directory. So great. Now we know how we can easily set up DTS. So let's talk about how we sort of integrated that into the CI lab automation. So the way that this sort of plays out as new patches come in is some developer submits a patch to the mailing list. We pull for that. When we see that happening, we use one of those DPDK CI scripts that I was talking about, specifically one called create series artifact. Again, that takes the new patch, or it takes the new patch series, applies it to the correct DPDK tree, and produces a compressed DPDK source that's going to get copied over to the SUT system. And then for each SUT at the lab, we basically set up a set of configuration files. So yeah, for each SUT, we decompress the DPDK tarball, we copy in the configuration files, and we, again, build this DTS runner Docker image and run that. So it's pretty simple. That will run, and that produces the output directory. And we basically have some basic bash that does this, and then it picks up the results JSON at the end. And sort of according to whether the test passed or not, it sends a passing or a failing test report to the test report mailing list. And we also upload the results to the community lab dashboard. So if you see results coming in on patchwork on your series, sort of that's how that's happening, at least from the community lab perspective. And I did just throw in, again, it's very simple, very short bash that we wrote in basically our Jenkins pipeline. Jenkins, the software that we use to drive the automation pipelines. But with some simple bash, right, we just get our DPDK tarball that has the new patch applied to it, decompress it, CD into it, produce that Docker image I talked about, copy in those two configuration files that we're maintaining on the DTS execution system, and clean up the output directory. And then we run the Docker container. This is all explained in the DTS docs, but I'll just clarify here. The reason we're -v volume mounting in this is that we're copying in our SSH keys so that the DTS execution can control the two nodes and be able to use those passwordless sudo users on the TG and the SUT. And we're volume mounting in the output directory just so that, again, as that output directory gets written to by the DTS execution, and then the container exits, we still have access to those afterwards, because we're going to have to look at those files and then consume them for sending their reports to our dashboard and to patchwork. Okay, bit of an eye test here. I won't go through every line here, but I just figured I would take some screenshots of what Jenkins is showing. So, some new patch came in. We applied it, we started executing DTS, and then so basically it runs through a test execution setup where it takes control of the two nodes, it gathers some system information, sets up the traffic generator, and then proceeding on, we get into a test suite execution. So it's going to basically take control of the traffic generator on one node, take control of the DPDK application on the other node, and it's going to send some arbitrary, testpmd runtime commands, say. Then it's going to start sending some traffic, and then, of course, we'll have some arbitrary assertion that's in the test suite that defines whether it's a pass or a fail. At which point, we get a result here, and the system cleans up. So again, that was sort of how we set up DTS, how we incorporated it into our community lab pipelines. And then now I'm just going to give a view of how this presents on the dashboard that we maintain. So this is some random patch that came in a week or two ago when I was making this presentation. And I guess it didn't break anything because everything's passing. But as you can see here, we've got a bunch of test suites being run. Some of those are basically the software tests, like the build and the Mason unit tests that I mentioned. I mentioned that we run on VMware, or basically on our VM cluster. And then some of the other tests are either the legacy DTS tests that we're still running on bare metal, or it's the set of new DTS tests that we're running on bare metal in the manner that I've just described. So digging one level deeper, let's say someone wanted to see the results from DTS for a particular set. And I'm taking the example of an Intel XL710 NIC, which is the one that was configured in the config files I went over earlier. They would scroll down on the dashboard and look at the particular test suites that were run on that set. In this case, everything was passing, so probably someone wouldn't necessarily want to look. But if it was a failing result, a person basically could come here and download the result summaries. That's going to be the stuff that DTS had produced in the output directory, or they can just open it within the browser. So if, say, you clicked Open Artifacts there for the buffer scatter test, you could, that would bring you to another page. You could extend that window and see sort of the test suite specific logs for buffer scatter, and sort of learn what you need to learn from the test suite logs. So again, that was sort of the whole process from having nothing to configuring DTS so that it ran, to writing a little bit of bash just so that our Jenkins pipelines could drive it, and it was not a big lift. So some conclusions and considerations looking ahead. So we set up this Jenkins pipeline and started having it drive the DTS framework a couple months ago. It wasn't a big lift, and it's helped us extend our test coverage. So that's been helpful for us. And the other final thing that I want to clarify is that because the new DTS framework exists within the DPDK repository, that presents one opportunity, which is that if you are writing, say, an ethdev feature, you can submit your patch series that adds that feature or modifies some existing function, whatever it may be, and side by side with that, as, say, a final patch in your patch series, you could update a test case in an existing DTS test suite, or you could even add a new test suite, whatever is required. So one benefit is that you can submit patches that are updating DPDK and patches that are updating the test coverage side by side, and those will come in together and get picked up by the CI labs together. A few more next steps to note. So like I said, we deployed this in the UNH community lab, but I'd like to work with, there is a broader set of CI testing labs that are all picking up patches in the manner that we are and submitting some test results to the public mailing list and up to Patchwork. So I'd like to work with those labs to help them deploy this testing framework on their hardware, so that we can help extend their test coverage. We've also got some DTS development that I want to call out, which is ongoing but relevant and important. So as an example, we've got like some patch series that are up on Patchwork and continuing to get development for supporting virtual functions. So right now, everything's running through physical functions, but we want to add the VF test cases as well. And we're also adding some support for performance testing and performance traffic generators. So there's another series on Patchwork that's basically adding performance TG abstraction layer and a support or an implementation for driving T-Rex so that we can run those tests where we send a high amount of packets and we validate that performance is still good. We're also still developing test suites. Like Tama called out yesterday that Dean over at UNH is writing an RTE flow test suite. So of course there were a number of RTE flow talks yesterday. Maybe when we submit that we can CC some of those people and maybe get a review. We're always helpful to get, always grateful to get help from the community. And I'm sure that that would be relevant to all of you people who are relying on RTE flow. So yeah, so there is still plenty of development which is in progress and is a part of the 2507 DTS roadmap. So we're going to keep pushing that forward. And then specific to the UNH lab, we're obviously going to continue adding more network cards and more test beds into the DTS pipelines that, again, I mentioned that we created earlier this spring. So that is a wrap. I wanted to thank some of the people that have been doing a lot of work that has made our usage of this framework possible. So Paul and Luca from ARM have done a lot of work over the past year and have been really instrumental in sort of the framework being as mature and useful as it is. I also want to thank Dean and Nicholas, who are students at UNH, at the UNH InterOperability Lab, and they've been writing a lot of test suites and some framework additions over the past year. So that's been really awesome. And I want to thank Aaron from Red Hat. He's a little bit less on the DTS side, but he's involved with the CI community, and he's been able to help us in a significant way, sort of in terms of the UNH lab operations. I'll point out finally that we do, if you are interested in contributing to this effort, we do hold DTS meetings every other Thursday at 1300 UTC. That's just running through like the Linux Foundation events portal, and I can add you to those calls if you're interested. So please come and talk to me if you're interested in the effort. Thanks again, everyone who participated in the DTS Birds of a Feather session. I think we got a lot of really good ideas from that, and a lot of ideas that are going to allow us to put the framework in a really good position for others to be able to come in and make good contributions going forward. So yeah, thanks to everyone for that. And then I'll open it for Q&A. That's all I had.
Quick one, I hope. Is there a list you've got published somewhere of all the test suites that are currently available in DTS and what the requirements are to run them? Because I know that there's a config file where you specify what tests you want to run in the test run. Is there a list somewhere of all the possible values for tests that you could specify there so you know what's already done and we can try them out?
Right. Yeah, so there's a test directory within DTS that contains the tests, and each of those tests will have like a doc string that contains the test plan. So I encourage people to go look in there and read the test plans and the test implementations. The way that those will work is that each of the tests basically will perform some capability checks to make sure that they can run on a particular system. This happens at runtime, and it's going through, at DPDK API, it's going through like test PMD, show capabilities. And you can also provide some test suite specific config files, and we have like an example config file that in the repository that you can look at. In actuality, most of the test suites don't require particular configuration for the test suite, although that's something that we expect to see more in the future as we start adding in more like performance test suites, because then you're going to have to want to do stuff like set expected baselines that you want to compare against, stuff like that. The test suites also populate up to the DPDK docs when you do a docs build, so it can be read there. But probably the easiest way is to just clone DPDK, CD, DPDK, DTS tests, and then they're all right there. So.
So, good presentation. Thank you. And I have two questions. You mentioned the new framework of DTS, and which is the earliest version of DPDK that includes the new framework?
Right. So I believe that the new framework was added as sort of a experimental work in progress with 2111, but that was an experimental work in progress.
Yeah.
It wasn't really useful for a couple of years. So I don't know about the particular every single .3 and .7 and .11 release, but I would say I can say with confidence if you check out to 2411 that it's a performant testing framework.
Yeah. Okay. You suggest the 24.11 to use. Okay.
Yeah. So it's performant on 2411 and also on mainline, of course. So current mainline.
Yeah. Okay. Thanks. And the second question is the result. Does the result include the coverage rate?
It doesn't include. So right, it doesn't include the code coverage that the test suite reached. That was a subject that got raised in the Birds of a Feather session. So I guess great minds think alike. There's a couple people that are thinking along those lines. So I mean, we're taking that down as a feature request, but it's not something that's available right now. Thank you for the idea, though.
Yeah, okay, thank you.
Thanks. And another one over here. Okay. Any other questions at all for Patrick? No, I think we're good. Thank you.